would like to talk about some opportunities which are coming to the testing and some challenges. So first, let me properly introduce myself, and I will start with the introduction of myself. Since last year, I start a startup called Wopee, and we are focused on autonomous testing. Before that, I was working on various different engagement in area of software testing. Before Wopee, I'm founder of Tesena. This is a 10 years old company where we deliver our testing services to our customers. And we also provide some training. And actually, that was the place where I basically find the idea of autonomous testing. But let me share, before we will go into robot framework on some technical part of the presentation, share some ideas, and I just call them signals which are coming to the market, and we should not ignore them. First, Gartner, you probably know the company. They said that autonomous testing is coming to the testing industry, and it'll eat up around 30% of the market of the traditional testing within a couple of years. Then if you look at the other different similar companies, Forrester, another company, says that testing bots will increase our productivity in testing by 20 to 30%. So this is something what you could find on the market, and some predictions are coming from these big companies who are scanning the market and trying to find out what's going on. So these are the trends on the market. And if you look on to the past, if you look on the history, maybe you saw already my slide about that a couple of years ago, actually it was, I don't know how much, it's a couple of decades, we started with manual testing, and then we find out that it's not the best approach, and we would like to find some more efficient way of doing so. So we introduced automation. And just a couple of years ago, someone says, okay, but automation is not good enough anymore. So what we could do next? What is the next stage, next era, or how we could proceed further? Because we already master automation. And this is exactly the question I've got from one of our customers, how we could advance or enhance our existing automation, how we could make it better. And people start talking about autonomous testing, about AI, about a lot of clever algorithms which could boost our automation testing. And that's the topic I will be trying to get into in my talk, but I will be using robot framework for that, because this is still a lot of theory, but let me start with the practical part. So first, for those who vote that they are not very familiar with robot framework, I will do just quick introduction of the tool. Sorry for the guys who already mastered the tool and they are gurus for the robot framework, but I would like to do a very quick introduction. So basically, a robot framework is the generic automation tool. You could use it for testing and also for RPA, which is some more people are coming for automation in, I would say, in production. It's cross-platform. It's built in Python, and it uses keywords. It follows some keyword-driven approach. Yes, robotic process automation, RPA. I was missing this one. Thank you, Tejas. So this is very quick introduction. I will just try to explain it with some Lego pieces, because I believe Lego is the best toy or best tool to explain anything. So I decided that I'll use the Lego bricks to do so. So you could imagine that you are building your test from the small pieces. In programming, we could say methods or functions. In robot framework world, we are talking about keywords. So you just introduce some low-level or high-level keywords, and you combine them and build the entire test or test suite. If you have these blocks, some keywords which we could consider high level, it might be something bigger, and you could have a small keywords like single activity you could use within your test. To do so and to simplify that, we are using libraries. Libraries are basically the way how robot framework implement keywords. That's it from introduction. Now I'll try to focus on that more advanced stuff. If you wouldn't be able to follow me, or you have some questions to clarify some parts, just post it into maybe chat. We'll see whether we'll use also Slido, but for the questions, post it into Slido. I'll process them at the end, and then we could follow the voting if there is more questions. So this is it about the robot framework. Now, let me start with explanation what I actually prepared for you. And I thought, okay, if this autonomous testing is coming into our industry, Gartner said 30% will be taken by this approach, and another company says, okay, 20-30% saving or I would say, efficiency boost by introducing some bots, I was trying to search for some ideas, and I decided to bring 7 ideas which you could use in Robot Framework. So let me start with that list. So 7 ideas to optimize or to improve your efficiency within the Robot Framework. To make it maybe more clear and to explain why I pick up these, I split it into several categories and basically into 2 challenges. When we are implementing anything in Robot Framework or basically in any automation tool, one of the challenge is how to make the assertion stable, because that could impact the flakiness of the test, how to make them robust enough, how to cover all the things we need to cover. So this is challenge 1, and I will bring some ideas what you could do with assertions. And then the second challenge is how to improve efficiency in interaction with our application under test. For that, I will be focusing on several ideas in both challenges. And if you remember the slides about these 3 areas, manual, automation, and autonomous, there was something like promise or signal from the last area that it'll be about AI, but I believe you could still improve your approach even without using AI. Of course, I have maybe 1 or 30% of the topics is about the AI, but I will be talking about very simple stuff which you could easily implement and might help you to make your testing better. So let me start with that assertion challenge. I'll explain why we even need to consider some improvements, how we need to deal with this, or what is the motivation behind. So imagine you have some checkout page where you need to provide credit card details and set up some quantity and then purchase in my case, some drone. I always saying bot and talking about the drones. And at the end, you just need to take this screenshot, which is confirmation, the screenshot, and then check whether you are getting the answer or confirmation that order was processed. So in my case, there is thank you for your order. Your drone is flying to you. So this is something what I need to check. And if I would write it in the robot framework, I would just provide some details of that each and every field and fill it in, and then click on purchase. And then I would be checking that some message with CSS class equal to confirmation contains thank you for your order. So this would be my test. Okay, but what if I would get this kind of confirmation? What about another assertions? Maybe I need to bring some more assertions, like is there header? Is there footer? Do I have this return button, return to store available? And many others I could introduce, like checking whether the logo is there or what are the menu options and so on. But this brings a lot of more efforts to spend on that assert, so I need to implement them. But this will also introduce a lot of risk that this might fail because of something changed or happened. I don't care at all. So maybe it is better, but maybe not. So maybe there is just missing CSS file or some images or something was not imported and so on. So instead of that, instead of this option, which is pretty valuable and typically followed, I could maybe think about something else. So apart from this, I call it option 1. I might have some other options. And one of the option might be, which I call lighter assertions, which might be global and might be technical. And these assertions we will now try to implement, and I'll show you some of the ideas. So what if I would check whether the status code is correct? What if I would check whether all the console logs do not contain any errors or warnings, because maybe there is something missing on the page? What if I would check whether loading time is not somehow different, because I'm not fetching any pictures, I'm not getting any details which I should display. So maybe I should see some dramatic change of loading time. So these are technical assertions, or sometimes I'm calling them signals, which could help me to identify some potential problems. And if you are experienced in test automation, that some of these asserts, the traditional ones, checking whether all the text, all the fields, all the menu items, all the colors and whatever footers are there, bring just more and more complexity into build and then maintenance of your test script. So maybe this implementing globally might help. So I was playing with this because what was my goal, or what is my goal of this talk? To try to find and show you opportunities where you could improve your efficiency of testing and bring it more to the autonomous side of the world. So first experiment was that I introduce my simple bot crawling your web app and checking only these parameters. To do so, I will switch to my demo project, and I will start with the first demo, where I introduce very simple code. Maybe I will finish one more slide, and before I will go there, let me see. So what I will now implement is basically just a simple web crawler, which will scan through the application and try to collect any JavaScript errors and warnings. So out of all these, which are listed on the 3 ideas, I will prepare the script to crawl the web page. I want to use a robot framework with browser library. For those who are not familiar with that, it is a Playwright wrapper for robot framework. So I will be basically using Playwright under the hood, navigating through the application. And to do so, I will use crawl side keyword from the library, which basically run through that application I test. I provide the URL of the website, and then I will crawl the app and check on each and every page whether the status code and console log is okay and correct. For that, I'll be using my demo application. Some of you might know that, this Dronjo, and I will basically collect all the potential bugs. So I provide my URL, then I will just set some global variables to count my errors and warnings, and then I will set the crawler to go maximal 3 steps into the depth, and I will crawl only maximum 10 web pages. To do so, this is simple code. If you would be interested in detail, I could share the code with you, but this is the test. And for that test, I could easily run it from my VS Code. So I already prepared that type of test. And when I run it, I could see that now the test starts, and I'm just scrolling through the Dronjo application, and I could see that some of the pages has some errors. And I know, and for the demo purposes, I know what's wrong on each and every error. Maybe first, let me show you the application itself. We were talking about that, and this is the app, and it navigates through the entire web page. I could see that in total there was 18 potential web pages or URLs identified, and I crawled only 10. And if you look on that crawler, I could easily see that some of the pages are broken. And let me see, I'll pick up the nice example, this one. So in this case, I could see that some error was identified. And there are still some people coming, so I'll just need to admit them. Okay. And we'll see. Maybe someone else could do that for me. So anyhow, if I click here, I could see, okay, it's opening always in the different, I could see that this is the page where there is 404 error, and combining this with the traditional assets could give me already some signals. Of course, in this case, I could see that the traditional asset would catch probably this type of bug. But let's see what's the second one. In the second issue, there is something else. And let me see, where is it? And in this case, it looks like here, another problem. Maybe we will find that, no, console. And okay, I will use my anonymous window, so we could easily see what's wrong here. And still someone is coming, yes. So in this case, there was some other problem, but it's not about the buy. And I think this is problem of formatting. Formatting is not very good here. I believe it's this page, contact page. So I will now navigate to the contact page, and I could see that there are some issues. And in my case, there is some problem with this map I generate. are the issues? So there is some problem with loading some map. And probably this is not very valuable for us, but I could see that with this concrete page, this loader doesn't work as we would like to. So going back to that testing, this is very simple assertion. I could crawl any page and I could get some errors and warnings. In my case, this broken link might be valuable. In some cases, not always. So this is one of the idea how we could identify potential bugs. If I would move on, apart from these three different assertions like loading, errors, warnings, and status codes, I could introduce another type of assertions which might be visual. And for that, imagine, or first, I would like to explain why this visual testing might be useful and why it might be a pretty stupid idea. So I decided that I'll first explain why this is something valuable. If you have specific assertions, like I showed for that thank you page or the confirmation of order, you might let some bugs escape into production. Imagine that you have this type of checkout, similar to the one I show you in the first example. And in case something is broken, it might look like this. Your automation would work perfectly because you could navigate through all the elements. You could even click on that white button on white background, but users would probably never fill in that sensitive data about the payment cards to the right screen. So this could be one of the reasons why visual validation could help, because the traditional approach might even check all that details that are on the page, but might miss something which is important, and it's how the web page looks like. Second example, imagine that you have this type of registration form. And if you want to test all the asserts, you need to check each and every field that these fields are mandatory. So you need to write the code to navigate to this page, submit the form, and check whether these fields are in red with these red circles. So the code would look like this. But if you would use visual validation or visual assertion, you might reduce the test by removing all that potential or all that implemented asserts, and then just compare screenshot which you saved in the past with the one you are getting as an actual result. Another example of visual testing opportunity, I would say, imagine that you have this pretty complex UI and you would like to check that this chart is correct. You need to set up your test data to let the chart behave as it is here. And then again, you just compare the screenshots with the baseline with the expected result you already stored in on your file system or in your tool. So this visual testing might bring you a couple of opportunities. These are just a few pictures I collect through my testing, and I believe it's clear that from the picture you could easily spot some bugs. I'm not saying all the bugs, but some bugs could be easily found just by checking how the screenshot look like. And you don't need to write any complex assertions. And I would like to also share with you when this is pretty stupid idea. So not always visual testing is the right approach. And I will try to explain it on the chart on the right. When you run your testing manually, you probably spot a lot of bugs. You don't need to have any visual automation. But the more you automate, the more you are getting rid of any manual testing. This is more and more valuable because you don't have any manual regression tests, or you have so little that some of the visual bugs might be easily just not noticed during the automated regression testing. So of course, this is more and more valuable. You have more automated tests. On the other hand, if you go to the extreme and you check everything visually, these tests might be like not very quick or slow. It might also introduce some stability issues or flakiness. So it's not always the best approach it's not a silver bullet, but in many cases, this might be a pretty nice booster to combine it with your traditional asserts. So this is basically, I would say, top 3 reasons why not to do it, or why this could be a stupid idea. When you have a lot of manual testing, when you automate it too heavily, you check visually too heavily because it might slow down your testing progress or test execution, and then also it could introduce some flakiness. Let me move on because I believe this visual assertions might bring you two benefits or two opportunities. One is increasing the coverage, because by taking a screenshot, you could test or check on the screen much more than just traditional asserts where you would say this need to be 14 or the currency is euro, or there need to be 4 pictures on the screen. And also it could help you to boost your coding efficiency because you could reduce some traditional asserts by introducing these visual checks. Let me show you some demo for that. And I'll be using our tool we are building, Wopee, but you could use any other. You could even build your own. I know that Playwright, and to be honest, I don't know how it's implemented in Robot Framework, but Playwright also provides some visual testing functionalities or capabilities. We also, as a part of Tesena, I was contributing to free library, open source library, which is called Watch.ui. So you could build your own testing framework or testing capability within your framework. But what we also providing as a part of our tool is some teamwork, history tracking, versioning of the screenshots, and so on. So many benefits which are not out of the box in open source solutions. So for the first steps, I believe the open source solutions are best ones, and I wouldn't suggest to go to something more professional one. But once you prove or confirm that this is valuable for you, I would really advise to search for some more robust solution rather than storing the screenshots on your local host or on your in your GitHub, which is sometimes also one of the approach. So let me show how it works. So in compared to the traditional assets, I could do it in a way, and we have a couple of options, but I will do it. I will try to make it simple. I will just write my traditional test where I navigate to the specific page, I log into application, and then I'm submitting the login screen, and then I'm doing some asserts. But in my case, I just call one keyword, which is Wopee check. In this case, this is parameter. I could even check visually after each click or after each fill or after any keyword, but I introduced a simple keyword Wopee check. And this is to, on that line 20, I will take a screenshot, send it into our validation backend, and return back to the robot framework whether the visuals are as it was previously. In return, I'll get into terminal status of the comparison. So I could see that in this case, the status is new. So we didn't store any information about the screenshot. So and then I get the link to our, we call it commander front end, where you could see the screenshot and approve or set that as a baseline. In that screens, when you run it first time, you need to approve. That's the screenshot on the left. Once the screen is approved and you run it again, we compare it with the taken screenshot from the last time. And if there is no difference, we consider it as okay and return back to robot framework that it's okay. You could also set up some thresholds. You can also set some areas to ignore in various ways, like we have some options for low code or no code, but this is not the purpose of this demo. I am trying to just give you the idea of how the visual testing could work, not the demoing our tool. But similar tools work similarly. Some of these features you could implement locally or within your repository. It might be a bit more complex, but in our case, it's just pip install the package we provide and set up config file, which has minimum 3 lines of configuration parameters. To do so, let me now move on. So if I run this test, then it is done in a way that I run the test with listener. For those who who are not familiar with listeners, listener is basically a small utility which watches your tests and collects the events and then sends the screenshots there. And once this is sent there, we compare. It wasn't there. Maybe I'll just replay the video. So let me now show you again. So once the test finished, I could see the result here in our commander. It's in status new. Now I click on approve button, so it'll become approved. And now I can run it again. And whenever I run it again, it compares with this approved baseline. So once I'm getting a new test execution, I could see that the screenshot on the left side is the one I approved, and there is no difference to the one I collect in the second execution. So that's basically it. I could see all the history of the baseline. I could manage various versions. I could ignore the areas and so on, as I mentioned already. And same, you could implement locally. If you would be interested in that type of idea, check out the Watch UI. If you're interested, I could send you some links to other options, and I could also show you in detail how this works. But basically, the idea is introduce visual testing. It might help you to reduce number of asserts you run. It could improve your test coverage because you are checking much more than just by writing down that the menu option home need to be there and so on. So this is basically just summary of that Wopee visual testing, where you could easily implement this approach with any framework. We currently support these 5: Cypress, Playwright, Robot Framework, Selenium, and WebDriver, and more will come soon. I just don't want to spend too much time on it. This is just for the marketing purposes, so other colleagues will be happy that I share these 2 slides with you. And we believe this could improve your preparation and expand the coverage. Let me move on now to the next one. And the next one is about if you remember, I was talking about 2 parts. One was how we could make our asserts more efficient. And the second part was about the interaction. So how we could introduce autonomous interaction into Robot Framework. And for that, now the AI part is coming. So maybe this is something what might be interesting for you. I will start with explaining why I even deal with that, because someone might say, okay, but browser library is so brilliant. I don't need anything more. I'm happy with that. I don't want to spend more time. I will do my selectors, and I know the keywords. I will just follow what the framework provide. But the biggest challenge is, and why there might be something better, and why it is worth to consider, is that we are still facing some troubles, I would say. Sometimes I was talking to, or not sometimes, last Friday, I was talking to one of our customers, and they said, you know what? We like the Playwright, but there are some different locators, and it's always difficult for me to deal with it. And then we dig into the details, and they said, but Selenium is the same. Cypress is the same. The locators are pretty painful to shape in a way that it will be stable and good. So some people don't know how to do how to write the selectors. And to be honest, it was pretty challenging for me when I was starting with the test automation. So when you are a manual tester and you want to start, this might be one of the big challenge for you. Sometimes people are saying, okay, but we just maintain all the time the same test. We don't have any time to build new one or create a new one because we are so busy with old ones because everything is changing all the time. Sometimes people even give up because they cannot keep up with the development. And if you go into some statistics, some people are saying, okay, 40% of our activities are just for maintenance of existing tests. So we almost half of our work time spent on maintenance of existing automation tests. Or applications change too often, we cannot keep up. And you would probably have your own reason why it is painful to create new test cases, and how painful it is to maintain them, to keep them up to date. And if you're adding more and more, the more difficult it becomes. So there are many of challenges in authoring and maintenance of test scripts or test automation or test cases automated in any framework, and in Robot Framework as well. So, but something changed just maybe, I don't know, 16 months ago, when the OpenAI introduced ChatGPT. I think the new programming language was or is nowadays text. So you don't need to do any programming, or you don't need to learn any programming if you can write like generic, ideally English, but also other languages text, because this is a new programming language. Actually, this is one of the inspiration for me from someone else. I don't know the author, but this is not my idea. This is something what I found on the internet. I found it pretty interesting. But let me share with some other inspirations before I will show you the Robot Framework code for that autonomous interaction. Another thing what inspired me was something from a company called Versal. They call it Versal AI Playground, and they provide a couple of various LLM models, so you can experiment with your prompts and prompting. And for that, I was playing with what could it offer for me when I would ask for some Robot Framework code. And you could see I could get pretty decent answer, I was asking about some code to fill form, and you could see that even the Meta Llama model was quicker than OpenAI. So there are a couple of opportunities or options nowadays we could use for automation. So this is something which is available nowadays on the market. We know that apart from OpenAI, there are already models from Google. There are also models from, I don't remember the company, Google and Amazon invest a lot into them. Maybe I'll prepare my cheat sheet next time for that, or I'll tell you later. But there are a couple of other alternatives, even Meta and on device run or local run of the models could be implemented. So this was one of the inspiration. I've got another one, and another one was GitHub Copilot. This is also a pretty old idea, but this brings me to the demo I'll show you soon. Because when I was building, maybe it was more than 1 year ago, when I was building one automation for framework or project for one of our customer, I just find out that this is pretty, how to say that, efficient, or it might be a nice booster for my writing of test scenarios. So you could see all this gray is suggested by GitHub Copilot. So I could get all that suggestions from GitHub, and I could get some first scenarios just get generated by GitHub Copilot, and it works pretty well. You need to monitor it, so it won't work like out of the box. It's not. It's something like you need to really read it, and if you are okay with that, it'll get better and better. But you could generate your BDD scenarios very easily. Microsoft claims that it saves 40 to 50%, I think. So it's doubles your speed. So this is one of another idea I was considering to use for my own autonomous testing scripts in Robot Framework. So first, I built for a conference in Bilbao for, I think it was in October last year, and I just implement one single keyword saying fill the form. And the test, what it does, it just search on the web page first form, and then it fill is in. And the second one was that I was trying to enhance this into multiple steps and create something I called BDD Copilot, which means I provided the Gherkin file, the step files, these features, which I demo from Copilot, and I let the keyword generate the low-level code, which means to interact with all the fields. So let me first show you how it works. So first, what I did, I implement this simple keyword on line 15, autonomous form filling. And for that, I provide URL to the same application I was using for previous demo. So I provide this URL, and I ask to get some let me see, some list of steps, and then locators and the data to use. So you could see what I've got, but this doesn't finish here. I implement within that keyword also steps to use these instructions to interact with the form. So let me now show you the demo. Again, pre-recorded, so we are sure that it won't break. So this is basically what it does when I use the same code I show you and explain. So I'm login because you can see logout button on the right top menu options. So this is how it works for the page, and I provide only URL. So now if I move on to the second demo, I took, and you might know Source demo app, which is simple eShop, but I don't care about the eShop, but I'll show you what happened here. As a part of my prototyping and experiments, I use the same keyword. And the only specific difference was that I only provide the form, not the entire HTML. So in first example, that keyword or that AI model got some signals what to fill in to log in. In this case, I skipped that black footer. So there was no information what should be filled in. So if you look on that, I'll probably use some pointer, laser pointer. Okay, if you look on these locators and the data to use, they are not following the instructions here. So let me show you what happened. It found all the locators, it was able to fill it in, but it fails to log in because the data used there was not following the instructions. So in this case, I couldn't log in. Will it start? What I should do? Okay, now it starts. So now I'm getting the data there. It even clicks on the login button, but it fails to log in because the data used there were not correct. So this is how you could implement your autonomous interaction with the app, which is still in some kind of experimental mode, but using the same code. If you look at the examples, it's same. 16 lines of code. I just changed the URL. I'm getting some list of parameters with some testing data and trying to navigate through the form. So this worked for me, and I understand why it fails for the source demo. And now I would like to move with that further. But before that, I would like to share with you how I implement this autonomous form filling keyword, because that might be practical for you and you could use it for your purpose. And what I'm trying to achieve is that these are the prototypes we are implementing in Wopee. So a lot of things are pretty challenged by one single requirement. It needs to be generic. We cannot focus on some specific application, but you might have that advantage that you build this for your application under the test, which might be much more specific. It might be CRM, it might be some e-commerce platform, it might be something which will make this even more efficient than we could use in Wopee. So let me now share how I build that, or what is under the hood. Basically, I'm using OpenAI API, and my robot framework code communicate with system under test, and on the other hand, it communicates with OpenAI. But you could use any other model. I just use this because it's so simple to use and so cheap. I spent to prepare this demo and entire the workshop last year, maybe $2 or $3 for entire experiment, and I was failing a lot with the first steps. So I had a lot of requests, but it's super cheap. And then what you need to work on is simple prompt. So this is the template I use to ask via the REST API. This is just example. You need to tweak it for your purposes. It might not work for you. There might be some issues on your application, but once you optimize this, it should be pretty nice how it works. So this is what I used. What is the magic behind the form filling? And then last idea on my list. Hopefully you are still with me. I see that not too many people left, maybe one or two. So this is the last idea. You could see that this fill form is pretty stupid in terms of testing. This is not real testing. It's just idea you could maybe turn into some proper test. So for me, that was like first step where I proved that this could work. And I'm still not there yet, but I believe with these ideas and inspiration, you could push it further and maybe give me some feedback in a couple of days or weeks that what you achieved with from here. So what I did, the next one, I implement the BDD scenario. So for that, I just create very simple test login where with 3 steps, given when then, you might know that. And you know the robot framework by default, it implements this given when then. So if you use given when then, it just cut it out and use it as a keyword. In my case, I use the given when then as a keyword. So there are 2 spaces, not one, as we are used to when we are following the BDD approach in the robot framework. But otherwise, it's the very similar or the same approach. And then under or behind these step names, I implement the same approach as I did for the previous one. And you could see what I've got after each and every step. This is not very, it's pretty raw still, but you could see that there are 3 steps. I didn't get any suggestion for source demo because I was already on the login screen as a first step. But on the other hand, for Dronjo, I've got first step to navigate to sign-in page before I could fill in the data into form. So if I implement one single step, like given I'm on the login page, for the source demo, the response from OpenAI API was like empty list of steps. For Dronjo, I was advised to navigate to the login page. Then when I fill in the login page, on the left side for the source demo, in this case, I provided entire HTML. So I've got much, or not much more, but better instructions, considering the instructions, what data need to be used to log in. on the right side, it was the same as the last time. And then I've got something for validation at the end. This is maybe the weakness part of that experiment, because that asserts on line 20 does not work so well as I would expect. So this is maybe the most challenging part I will need to work on to improve and polish before this could be, I would say, production ready or testing ready, I would say. So let me now share with you some quick recordings. So this is the first source demo. In this case, it doesn't navigate anywhere. It starts from that first page, and then it logs in. So now I was successful and I was able to log in. And now let me move on to the next example. Now, this is different because I'm starting on different page and I need to navigate to the login page before I could log in and provide data. So in this case, I could do it. I need to first navigate. I'm there. Now I need to wait for getting some suggestions. Once I get it, it'll take some time. Actually, I was trying to trim all the beginnings and end, but it's not so maybe quick as you would expect. So now I'm logged in, and that's it. So this is my BDD scenario and the results. What I would like to talk about as a next step, what we are working with, we are working on this idea to bring it into simple form. You provide just project name and URL and create your project. And we generate all the levels of the test. So we are able to create the steps and then low-level code as well, just out of the one single box, one single form. So you could easily do it. We have first working functional tool, which you could use. But we know that there is still a lot of work to bring these ideas into tool to make it more robust and increase the coverage. So if you would be interested, just go to Wopee.io and you could easily try there. There is a free trial for you if you would like to play with it. But this is not about the coding anymore. We just need your URL and we will provide the tests for you. It works in a way that, as I said, you provide a URL, we scan your app and try to find out how it works. And then you just run your test cases and generate the test results. Let me summarize because maybe it might be too long for you. We are running already 1 hour and I would love to get some questions. So if you didn't post yet, think about some, because speaker is happy when it gets some questions and you are still with me. So I believe it was interesting for you. So post it into Slido or chat and I will just quickly summarize. So what I was trying to share with you, I'll start from very beginning. We are searching for better test automation. Some people call it autonomous testing. For me, it's just better automation. There are a couple of challenges, and I selected or picked up for today just 2. It's not easy to build efficient and robust assertions, and same is true for interaction with the application under the test. There are a couple of options what we could do with it, starting from very simple technical assertions, which could be globally applied and give us some signals, through the visual assertions where we could increase our coverage and boost our coding efficiency. But also for the interaction, we could find a way where we don't need to bother anymore with locators or changes of the app. Of course, there are some risks, there are some problems. And I believe that this is just beginning of that era. And I believe that these will still require some tweaks. If I would talk about the autonomous part, when I was building the prototype or demo, maybe 6 months ago, I couldn't take entire HTML page and pass it via API because the context was too little. Nowadays, it's available. I couldn't run it because it was heavily slow. It times out. I need to increase the timeouts to make it sure that it works. In some cases, I'm getting incorrect results. So I need to tweak the prompts. I need to play with some retries, which are not implemented, or some caching to make it more robust. And in some cases, when I ask that LLM models, they are not very fair in assertions. So sometimes it's pretty difficult to find out whether I'm really logged in. So this all needs to be tweaked and improved. But I could see the signals, I could see where it goes, and we want to be part of it. And I'm inviting you to be part of it as well. So hopefully you enjoy that some piece of inspirational ideas, and happy testing. Thank you very much for joining. I'll now go through the questions. And again, I would love to hear from you, your opinions, and also your questions. If you would like to keep in touch after this webinar, I'm happy to talk to you. Just contact me via email or on LinkedIn. I'm pretty active on the LinkedIn. You could also follow us on our Wopee.io LinkedIn profile. We are trying to share some content there as well. And we plan to also run similar session for Cypress and Playwright. I'm not promising that it'll be exactly the same, but many of these principles could be easily applied to Cypress and Playwright. Now we started also with Webdriver.io, where we are now prototyping some or getting some first experience with mobile test automation, but we are at the beginning, and I believe this will be the future. We will improve our automation and in some cases even reduce by replacing fully autonomous approaches. We work on both.